when you're good to go.
All right, recording.
Perfect. So welcome everyone, and welcome to another Hyperledger Netherlands webinar. My name is Rudolf, and I'm the founder of BCNL. BCNL is the community for blockchain, crypto, and DLT startups and scale-ups in the Netherlands, and we are the official community lead of Hyperledger in the Netherlands. I hope you're doing well in these hectic times, though, and you managed to adapt to the new social distance society. This event is part of BCNL webinar series, and in this series we provide you with relevant talks from blockchain entrepreneurs and experts on several use cases and industries. Well, make sure to sign up for those webinars, and they will be shared via video channels. So today we will dive into Hyperledger telco use cases with Telefónica and Deutsche Telekom. Got some important notes. The session takes around 1 hour and will be recorded as said. Please ask questions during the Q&A, which is after the two presentations. First, Alfonso from Telefónica will present right after Andreas from Deutsche Telekom, and that's followed by the Q&A. So let's get to it. Alfonso, the stage is yours. Could you please share your screen?
Okay, but I cannot access the sharing screen. I'm trying to share it, but I don't have permission, I guess.
Oh, whoever's sharing needs to unshare. We were doing a test earlier.
Oh, okay. That would be me.
Okay, great. Thank you for testing. And yeah, now you should be able, yeah.
Okay, now I am. Perfect.
There he is. Thank you so much.
Thank you very much, Rudolf. So I don't know if everyone see my screen now. I guess so.
I see a sign that says double click to enter full screen mode. It does look like you're sharing something, but it's
okay.
really playing screen.
I'm not sharing anything, I guess.
There you go.
There it is.
Now you can see it, right?
Yes.
Okay, so hello everyone. My name is Alfonso Rocha. As Rudolf said, I'm from Telefónica. Actually, today I'm going to share a talk that I prepared for the Hyperledger Growth Forum of this year, but I didn't have the chance to go there. So I said, okay, we're going to talk about going into production and performance best practices with Hyperledger Fabric. We did a performance evaluation of Fabric that we wanted to share with the community. We didn't have the chance in the Hyperledger Growth Forum. So what we did is to write a series of articles and do this meetup in order to share all of the results with you guys. Here you have some of my social networks and access to my weekly newsletter. There in my weekly newsletter is where you will find the in-depth articles of the results we reach from this performance evaluation. But I will do an overview here today. So I'm here to tell you a story, and it's the story of how we tried and we succeeded to move Hyperledger Fabric or a Hyperledger Fabric network into production.
Can everybody mute, please? Can everybody mute, please? Thank you.
So, as I was saying, we started, as I think everyone started, with Hyperledger Fabric. We went to the building your first network documentation of Hyperledger Fabric. We had an idea of a use case that could make sense using Fabric. And we said, okay, let's start building it. So we set up our first network, we implemented our chain codes, we did our application, and it was all great. I mean, we were in POC, we were having test users, everything was working fine. But when we moved into production with real users is when things started to break. And the load was increasing, our stress was also increasing, and we started to wonder several things here. So first of all, we didn't know how much load could our Hyperledger Fabric network and our infrastructure support, and this was really uncomfortable. We didn't know how many peers to put in our network. We didn't know how to scale our infrastructure. I mean, if we end up succeeding with this use case and we have even more load that we were accommodating, how would we scale the infrastructure? We didn't know if we were implementing the SDK correctly or if we designed our chain codes correctly. We started having with high loads something weird called MVCC conflict errors, MVCC phantom conflict errors. So we said, what the fuck? We don't know what is happening under the hood with high loads. And this is the reason why we jumped in and started our own performance evaluation of Hyperledger Fabric because we wanted to know several things. First, where were the bottlenecks in Hyperledger Fabric, or how to move a POC into production. And afterwards, we were really interested to know how much it cost to have a Hyperledger network in production. So fortunately, there was a lot of good research. We started reading a lot of papers. This first paper actually is really, really interesting if you're curious. And it was released when we were almost finished with our performance evaluation, and it was actually fine because that way we confirmed many of our assumptions. And okay, these papers were great, but they had a problem, and this was the reason why we jumped into our own performance evaluation. These were really academic papers, so they were focused on isolated environments with really specific use cases, with unlimited hardware, and we wanted to understand how Hyperledger Fabric behaved when we have a limitation in terms of hardware, when we need to fine-tune a production system with interaction with real users and real systems, legacy systems even. And we wanted to know how much it cost, because as I've said, if we have unlimited hardware, we just host a network in a huge cluster and that's it. But we didn't have unlimited, I mean, we have it, but we didn't want, for a cost model, we didn't want to have unlimited hardware. And as I said, we wanted to do the evaluation in a real environment. And you may be wondering by now, okay, you are talking about an application that you moved into production. What is this application? So to give you a bit of context, this is what we were trying to move into production. That is Telefónica's TrustOS. In the end, TrustOS is an abstraction layer for DLT networks so that anyone can build a Fabric-based or a DLT-based application just with some knowledge of web development without having to know about transaction, blocks, cryptography, and so on. And these are some of the modules we have already in production in our TrustOS. And the core engine of this TrustOS product is a Hyperledger Fabric network. Actually, another reason why we started our own performance evaluation is because we were changing a bit the approach we followed around Fabric, because usually, and you may have seen already, applications over Hyperledger Fabric that are really specific for the use case. So you build a network specific for the use case to be hosted in that infrastructure. But in our case, as I've said, we're trying to accommodate many applications over the network of many developers. So what we wanted to do is a performance evaluation of a dynamic multi-client general purpose network. That is the one that the Telefónica TrustOS uses. In this type of network, all the members can interact with chain codes, deploy their own applications. So we couldn't expect a specific load for the network. And that was why this was a really dynamic environment. For the experiments, what we did is, all the tests we did were over Hyperledger Fabric 1.4.4. We scaled the number of peers. We tried with different databases. For the ordering service, we used Raft with different number of orderers. All of this was hosted over a Kubernetes cluster, measured using Prometheus, and the load was generated, the user load was generated for the test using Gatling. And one last piece here is the HF service that you see here. So instead of using, in order for our TrustOS, instead of using the Fabric SDK from scratch for each application, we abstracted the functionality of the SDK in a client that we called the HF service. So whenever you see in the presentation that I refer to the HF service, in the end, I'm referring to the Fabric SDK. And this was our experimental environment and where we started doing our performance evaluation. So we didn't really know where to start, of course. So we wanted to see where were the bottlenecks, but we didn't know where to start. So the first thing we did was to divide the Hyperledger Fabric stack into these 5 layers. The infrastructure, that is the underlying infrastructure that hosts the physical resources that host the Hyperledger Fabric network. The architecture, that we refer to this when this is the topology of the Hyperledger Fabric network, the number of nodes, the number of orders, the databases we used. Then we wanted to study the protocol, the actual protocol that rules the operation of Hyperledger Fabric. And finally, the chain codes, our implemented chain codes, and the SDK. So let's start with the infrastructure. We did a lot of tests in which we tried with different number of resources, different topologies of networks. And the two things that we realized here, and two key learnings from this layer, is first, be sure that you always have enough resources to host your network topology, because if not, you will face really weird errors, and we'll see an example in just a bit. And secondly, be sure that you have low network delays in the communication between the different entities of the network. I mean, we had a lot of difference in the performance of networks according to the latency of the different entities in the network. So with all the tests that we did at this layer, these were the two key learnings. We even tried to have a Hyperledger Fabric hosted on bare metal compared to Kubernetes, but in our case, as we wanted to be in production, it was easier to host it in Kubernetes for our operational team. And I said that if you don't have enough resources, you start facing weird errors. And this is a fun example of what happened to us. We were doing some tests over a topology where we weren't giving enough resources to our peers. So we started with high loads, we started getting this error. Peers were throwing TLS handshakes errors. And we were saying, okay, what is happening? I mean, we have our TLS certificates correctly configured, our communications are working, so what is happening? And the problem was that peers were running out of CPU, so they weren't even able of doing the TLS handshake. So these are some of the weird errors you may be facing if you don't have enough resources for your network. And you may be wondering, okay, so how can I calculate the number of resources or the number of CPUs I need to accommodate my topology? So that's what we answered in the architecture layer. So we said, okay, we tried with a lot of different topologies with different number of endorsing peers, different number of orderers. We played with the CAs, we did a lot of things because we wanted to understand the computational profile of each of the entities of a Hyperledger Fabric network. And what we realized here is, first, if we want to scale our infrastructure, if we want to have a high transaction throughput in our infrastructure, we need to scale in the number of endorsing peers and in the number of channels, or in the number of channels. Because the more endorsing peers we have and the more channels we have in our infrastructure, the better performance we will have in our network. Of course, we have to bear in mind that we have to always have enough physical resources to accommodate this topology. So the more endorsing peers we have, the more CPUs we will need in our underlying infrastructure. So with this in mind, we answered one of our worries, that it was how to scale an infrastructure if we scale in the number of transactions per second in our system. Then related to the orders and the CA, I mean, they are not as intensive in terms of CPU, so we shouldn't worry that much. I mean, we saw some cases in which you should worry, but we shouldn't worry that much about them. So we have to worry about channels and endorsing peers and having enough resources to accommodate that topology with them. We also did some tests related to the database. A lot of people have written about this. This is nothing new. Of course, LevelDB, as it is an in-memory database, has better performance than CouchDB. But in my opinion, it wouldn't be directly, if to use CouchDB, LevelDB, it's not a binary decision. It depends on your specific use case, because for instance, for our operational team, they told us that they were more comfortable with CouchDB because they knew how to manage databases, and for high availability, it's easier to manage a CouchDB than a LevelDB. But of course, if you want a high performance and write a lot in the ledger, go for CouchDB because it would give, for LevelDB because it will give you better performance. So as I've said, we managed to answer one of our main worries, that it was how to scale a network. And the answer for us was to scale in endorsing peers and channels, but of course, always with enough CPUs. If not, I mean, I cannot stress it enough, you will face a lot of weird errors. So the next layer that we evaluate was the protocol. In this case, we didn't want, I mean, we had some ideas of things we could do to enhance the protocol, but we didn't want to touch the protocol at all because we didn't want to have and maintain a fork of Hyperledger Fabric. So that's why we just messed around with the configuration in order to see what was best for performance. And a few things here, the version of Hyperledger Fabric that you use will definitely affect the performance. As I've said, our tests were with Fabric 1.4.4, but if you go down to 1.3, you'll see that every new version has performance improvements. The best way of checking what has been included in each version or what to expect is to go to Fabric's Jira. I mean, everything is really well documented and you have a lot of information of what are their plans related to performance. Also, you can go to the release notes. Here, for instance, in the release notes of Fabric 2.0, we already see some changes that may improve our performance so that, I mean, we have to do tests again with 2.0 to see how better it gets with these changes. But what I'm saying here is be careful the version of Fabric you use because it will affect your network performance. And in the protocol, we didn't, as I've said, we didn't modify anything. We just messed around with the configuration, and some of our learnings were the following. First, validating signatures is an expensive operation in the transaction lifecycle. So if you use endorsing policies, as far as you can, use the less parties involved as possible in order to have a high throughput, because if not, I mean, the more signatures you need to check, the performance will be worse for each new signature. We played with a number of threads on the underlying infrastructure. We fine-tuned CouchDB. All of this is in some of the papers that I mentioned above. So, I mean, they also played with these configurations to improve performance. And another configuration that actually gave us good results for us, considering that we couldn't expect and we couldn't predict the load we would have in our network, was the block size, the number of transactions per block, and the cut timeout of the block. For us, for 2 seconds and 10 transactions per block, we had pretty good results with a dynamic load. I mean, when we don't know if we will have low loads or high loads, because if you have low loads or high loads, you will want to modify a bit these metrics. So that's all for the protocol. Then we started evaluating our chain codes and how we design chain codes. And let's be honest, when we started with our POC, we thought that we were doing a great job here in chain codes, and nothing further from the truth. We were a bottleneck in our use case, because with low loads, everything seemed to work. But then when we moved to high loads, we had to refactor all our codes. And the learnings I can share with you here is, first of all, use invokes and queries in a smart way and as atomic as possible, because of course, use invokes whenever you have to write in the ledger, because it goes to the order and they are way slower than queries. So use queries only when you have to read from the ledger, invokes when you have to write from the ledger, and try not to mix them. Use them as atomic as possible in your chain code functions, because in that way you will get the better performance. The second learning, and this is one of the most important ones in this layer, is to avoid MVCC conflicts. As I've said, when we were testing with high loads and with the old not refactor chain codes, we were facing this error because two transactions were trying to modify the same value, the same key, sorry, at the same time. And we were only facing this problem with high loads when two transactions, when there are race conditions and stuff. So the best thing you can do is to try to design your data model to avoid completely these potential MVCC conflicts. We also played again with how we designed our keys when we wrote in the ledger. And what we realized is that if we use random IDs for the keys when you write in the ledger, it's, I mean, because of the B-tree caching strategy of CouchDB, you will get better results. And finally, whenever you go to CouchDB, there is some kind of latency. So try to minimize in your chain codes the times you have to go to CouchDB to get data or write, because in that way you will get a better performance at a chain code level. As I've said, one of the key problems when you design your chain codes in order to be performant is to avoid MVCC conflict. We did a lot of research around MVCC conflict. Fortunately, this is an issue that in the database field and in the design of database systems, they have already faced. And if you're interested in this, please check the series of articles that we shared. I'm not going to go in depth with this, but what we realize is that there are different strategies we can use when we design the data model in order to minimize these MVCC conflicts and to avoid that two transactions are modifying the same key at the same time. And also something that it was great to realize is that all of our chain codes are implemented in Go. And in the end, a chain code is a Go application that can be profiled. So one of the things we did in order to see all of this and to evaluate the performance of our chain codes was to profile our chain codes using pprof. So what we did is take our Golang chain codes and profile them as if it was a standard Golang application in order to realize what was happening. And finally, and I don't want to extend more this discussion, the SDK, another disregarded part of our application. And it was because we weren't understanding how the SDK worked under the hood. And we were, again, with low loads, things were going fine in the POC, but then when we moved into production and with high loads and we started our benchmark, we realized that we were making some mistakes when we designed our SDK. And some things that we learned is first, where the SDK points or what entity in the network the SDK points for the transaction lifecycle matters for performance. Try to point with your SDK an endorser peer and the master order in order to minimize the communication overhead in the network for the transaction lifecycle. We also did a lot of tests of moving the SDK around to see how many SDKs should point in different topologies. And what we realized is that the best performance was achieved when we used a one-to-one mapping between SDK and endorsing peers. This means that for each endorsing peer, we had an SDK and an SDK endpoint pointing that endorsing peers. And finally, something that may seem like dark magic for someone that if you haven't played with the Fabric SDK, but one of the things that we suggest is that you reuse the clients for the same user and you catch the context in order not to mix context between users. When we started with the SDK, what we were doing is to have the same connections for different clients and start moving around the context because we thought that it was the best approach for performance. But our problem was that with high loads, this worked fine in the POC, but with high loads, the user contexts were being messed up and mixed, and we weren't following the transaction life cycle correctly. So, it probably makes no sense now if you haven't played with the Fabric SDK, but once you read the documentation, reuse clients for the same user with cached context in order to avoid many, many errors. And this is all in terms of the SDK. One last thing, when I said the one-to-one SDK mapping, this is what I was referring to. So we have two endorsing peers in this example. We will have two SDKs and a load balancer before balancing the load between the different endorsing peers. With this approach, it was the one that with which we got the best performance. So we really recommend this topology in order to get the most out of your infrastructure. And this was all that I wanted to share with you. I went pretty quickly because it was a really dense work and we did a lot of work with this. Again, if you're interested, we published throughout the last month a few articles in a series where we go in detail of all the tests we did and all our learnings. And from all this experience, what we can get is, I mean, I leave you with this message. Get ready for blockchain in production, because it was a hard quest, but blockchain is getting ready, step by step, is getting ready to be in production. So thank you very much. And that's all. Thanks.
Thank you so much, Alfonso. It was great to see your insights, and thank you for sharing your experience on this particular project. May I ask Sir Carl Weaver to please mute your microphone?
So sorry.
Yeah, that's no worries. That can happen, but we sometimes hear an interruption, so that's why. Then let's move to Andreas Sommerwerk from Deutsche Telekom. Andreas, are you ready?
Yes, I'm here. Hello.
Perfect.
So let me share my screen. So that should work now.
Yes, we can see it. Go ahead, please. Thanks.
Okay. So yeah, my name is Andreas. I work in DT, Deutsche Telekom, in the innovation lab in Berlin. And I'm part of the blockchain team there and leading the telco blockchain activities. So we have various blockchain activities there. And the telco ones are the ones that I would like to talk to you about in the coming minutes. So my background is not really technical. I have a service design background, and so my role is to match the requirements of the business to the possibilities of technology. So the presentation has a bit of a different focus than from compared to Alfonso's, but I think it's a good complement because it's less technical and more focusing on a business proposition and business use case. Let me just. So the topic that I'm dealing with, our team is dealing with, is the wholesale roaming process. So wholesale roaming is a process that involves operators. So it's not a customer-facing process; it's a B2B process. As you know, when you're roaming in a foreign countries, then you can still use your home operators. You still your home operator's SIM. That is the customer-facing process. That it's pretty easy. You get out of the plane and you can use your phone anywhere around the globe. But behind that, of course, there is also a business process, and there is also, of course, money flowing between the operators. So even in the European Union, where we don't pay anymore for roaming as end customers, there's still money being moved around on between the operators, so on that level. And this is what our project is focusing on, because you can imagine there is a lot of data that needs to be taken into account, and there's also a lot of money actually that's being moved around between the operators. So the process looks pretty straightforward. So what the operators do, they have contracts in place where they define the commercial conditions. Those are basically just monetary values that are assigned to the different services. So you say, okay, we agree on 1 cent per mobile call to certain destinations, or a certain amount of money for mobile data and text messages and so forth. So this is what you do in the beginning, mostly on a yearly basis. Then over the contract period, you are tracking the volumes. So every call that is being made, every data session that is being made is taken into account and being recorded. And then at the end of the period, you do the settlement. So you see, okay, how much data has been used, how many minutes have been used, and this is the process in a nutshell. And so there's a couple of hundred operator relationships in place in our case, and that's also mostly the same for the major operators worldwide. So there's different, I probably won't go into the details here, but there's different problems with each of these process steps. So one thing that really surprised me when I started working on the topic is that the contracts are all paper-based. So even though we are a very digital company, these contracts are actually printed out, signed, and then sent via snail mail around the globe. And then a couple of weeks later, you get the contract back signed. So it's a very, very old-fashioned process. Then the contract needs to be put into the system, so the correct rates are being applied. Tracking volumes is also quite challenging, just because, of course, of the number of sessions that happen. So I think in the course of just one day, you have around 150 million records being created. So that's quite a lot. And also here you have third parties that are involved, so data clearing houses that help us with that. And then in the year end, there is also a lot of work involved in the settlement, because there's discrepancies between the volume tracking between the parties. So sometimes there are some records being tracked only on one side, and these discrepancies need to be discussed, and this is also a lot of manual work. Sometimes also wrong rates are being applied, because the rates that have been agreed on in the contracts are not have not been implemented into the systems. So there's a lot of problems that arise due to the complexity of the process, and also the inefficiency that you have in every of those process steps. So what we said is, okay, for fast results, we start with the contracts, because it's not too many. I mean, 400 contracts per year, and then some signatures. So that's a couple of hundred transactions on a blockchain per year. So this means we won't run into problems here. Also, the amount of data is not huge. I mean, it's a contract that has some information on pricing. That's all. So we thought that we are on the safe side here when it comes to number of transactions and data volumes. And also, we were basically working on a process where there were no legacy systems, because you had everything on paper. You did not need to interact with legacy systems, as you usually would have to do in a telco context. So this is why we said, okay, let's start just with the contracts to see if we can make it work just for the contracts in the beginning. So it's more or less a digitization project that we started with. So, but still, even though it's just one part of the process, we see that there are already results that help us shape the process in a more efficient way. So we are moving from something that is time consuming and error prone and pen and paper and manual to something that is fast, reliable, secure and transparent when we work with blockchain here. So what we achieved is we built a prototype for that, for the contracts based on Hyperledger Fabric, and also tested and implemented it with other partner operators. By the way, Telefónica being one of them, but also with others. And settlement, so the last step is our next step in the development, because the volume tracking is probably the hardest step to take due to the amount of data, as you can imagine, and also the complexity that lies behind that, because there's a lot of different data formats. So there's no standard for that. This is why we kept this as the last step. So one of the key learnings that I made during this process is that when you do a project like this, so you say, okay, we want to see, is this actually working as a business process for us? Most of the time you are not dealing so much with blockchain technology, but you deal with a lot of other stuff. So like governance, legal, UX, data protection, system and integration, data routing, and the like. So this is what takes up most of the time of the team, actually. So talking to lawyers and regulators and so forth, and of course, if you connect to another operator, then most of the time you're discussing how you're getting through firewalls and stuff, and not so much how the blockchain actually works. So this is probably an interesting insight. So also what you have to think about is the legal framework, because I mean, it's nice to have some kind of prototype where you can simulate contracts, but we wanted to go all the way. So we wanted to see if we can actually make this something legally valid between operators. And so what we did, just as a brief description here, is that we split up the current paper contract into two parts. So you see that there is a framework agreement that we did. This is still pen and paper because you need to do that at least once. So you put stuff like definitions in there, and also a lot of the clauses that don't change over time. And you say, okay, from now on, simply said, we are doing the commercial agreement over blockchain. So this is the legal construction that that we agreed on. And then what you have is you have the bare commercial conditions, which you can which we first put into an Excel sheet so that we can actually see what is required by the commercial department, because Excel is the tool that they work with, of course. Then we translated it into machine readable JSON file, and this is what goes as a hash onto the actual blockchain. And of course, this is also accessible through a UI to the commercial managers that negotiate the deals. So we selected Hyperledger Fabric for various reasons. Probably the most important reason for us was that there is the inbuilt CA, so you know who is doing what on the network, which is very important from a legal point of view, because you need to be sure that a contract is signed by the right organization, so by the actual entity that you are dealing with, and also by the right person inside that organization. So there's signing regulations and rules in place in all larger companies. So depending on the volume of the contract, only certain people can sign a contract. So, and Hyperledger Fabric is the right technology to keep track on that. So this was one reason. Besides the many other reasons, so that is open source, that's secure, and that there is a rather high transaction throughput and so forth, that we probably all know. So this is just a glimpse of how, I mean, it's just a UI for the contract managers. So there is a list of contracts. This is sort of the inputs that can be made then for the commercial conditions, different implementations, and there is also a blockchain, kind of a blockchain explorer where you can see what is actually on the ledger. and what data the transaction contains. So of course, as this is something that you do with partner operators, we are also involved partners here, and also the GSMA as this standardization body of the mobile communications industry. And we are actually working in a working group also with our friends from Telefónica and 6 other operators to actually standardize this as a solution and to build the first interoperator blockchain network for the wholesale roaming use case.
Ay, estoy roncoso, no. Ay, no, estoy haciendo
Could you please
cosas.
mute Ignacio Varese? Thank you.
Plus, we also have T-Mobile US on board, which is our partner company in North America. So again, also you can imagine that the partnering is something that that we need to do, but that also brings further complexities to the discussions because every operator has their own views. But one consensus that has been reached now that for example, is that for the first prototypes that we are building together, we also will be also using Hyperledger Fabric. So I think we are on a good way here to actually work together with the GSMA to create something that is going to be the industry standard in the near future. Also, forward-looking, we see that there is more use cases in the telco area. So roaming is just one. Fixed voice, data on demand, and fiber to the home. These are also use cases where you have wholesale scenarios and B2B scenarios, which are very similar to the wholesale roaming process. And this is just sort of an outlook what we might do in the future once we have more clarity and something more concrete in the roaming use case. Yeah, and that's it from my side. So happy to take questions. Thank you.
Thank you so much, Andreas. Great presentation and insights. We got some questions in already, so please keep them coming. We will try to answer as many as possible during the Q&A. And please mention for whom the specific question is. Let's start with Alfonso. Quite a lot of questions came in for you. Let me see. Did you have an issue with log file sizes and requirement on storage? Ahmad is asking.
Okay, the answer is no. But to be honest, this is something that we have to check because our networks were short-living. I mean, we did our test, we did different topologies of networks, and our production network has been on for 6 months now. So we don't know if this would be an issue. Apparently, it won't be an issue. We are thinking about ways of fixing it if this comes to be an issue. But I cannot give you a specific answer because I don't know.
Okay. People are also asking if there's a place where they could find additional information about your tests and research.
Okay, so I think they shared already my newsletter. That's what we have for now. But I mean, we're planning to generate more documentation. This is an ongoing work. I mean, we are already doing we will start doing some tests over Fabric 2.0. We want to test things that we left behind. Because our deadline was the Hyperledger Global Forum to give a first bunch of results. But of course, our network is now in production. We are facing other issues, and we will most probably generate more content. I can give you my newsletter. You have my social network, and I can give you the links of my team also. And you can contact any of us, and we will keep you updated. We are constantly updating with information we find, with interesting content, and we will definitely generate more content with the test we are ongoing right now with Hyperledger Fabric 2.0.
Perfect, perfect. Kamlesh, thank you for sharing the newsletter. Martijn Rutte has a question as well for Alfonso. Do you have any comment on the stability? Is there given enough CPU for endorsing peers? Is that question clear enough, or does Martijn want to add something to that?
If he can clear it a bit, it would be great.
Martijn, are you still there?
Yeah, sorry. Yeah, just general say stability. Things crashing once in production. Do you see that the peers are stable? Do they restart a lot in Docker? Things like that.
Okay, that's a really good question. So it depends on the chain code. It's true that our chain codes have been really tested already, so we're not facing these problems anymore. But in development, this is something we face. So I mean, a wrong request to the chain code or a lot of load into a single function, we faced some problems in which the chain code failed and it made the whole peer fail with high loads. And also when there were problems like MVCC, a lot of MVCC conflicts could make the chain code fail. So that's why I stressed to have really well implemented the chain codes and the design in order to avoid these kind of problems, because we even tried to have chain codes as system chain codes, and this was a problem also because every single mistake made because we thought that, okay, this could make sense in order to have a better performance, but every single mistake made the peer come down. So we had to be really careful. So in the end, it all comes to the stability, comes to the stability of your chain codes, I'll say.
Thanks.
Cool. Andreas, Dave Pika got a question for you. For the wholesale roaming contract, is it mandatory that all roaming partner operators are on Hyperledger Fabric as well? And is there any interoperability possible with partners who might be on other blockchain technologies?
Currently, we only use Hyperledger Fabric, so the answer is yes. Everyone has to be using Hyperledger Fabric. In the future, it will be probably possible that we also support other DLT technologies, but for now, well, this would be now a longer discussion, but for now we are on Hyperledger Fabric, and in the future, possibly we will also support others. The question is this necessary or not? But again, this would be now, we could have another session on this probably.
I understand. And then Amat is wondering, what tools did you use to digitize the contract agreements?
Blockchain. So, so the front end template that you've seen, so the UI is a very straightforward UI, and this is not I mean, this is not the focus of the project. The focus really was to how to ensure, also from a legal perspective, that we can digitize contracts, and you can only do it with blockchain, in fact, because if you need to prove later on that a certain transaction, in our case is a signature or contract information, is actually the one that you agreed on, then you need something immutable and something distributed, actually. So this is why we think that blockchain is probably the only technology where you can fully digitize something. I hope this answers the question.
Yeah, and it partly also answers the question of Rahul asking, why did you decide to use blockchain to solve this use case? It looks like you are really solving issues because the use case was not digitized and was based on paper processes that could have been done using existing technology stacks. Would you like to respond to that?
Yes, I don't know which stack would be suitable for that, given the legal requirements that you are having. So you are, I mean, these transactions are worth a couple of million US dollars, euros, whatever. So you need to be pretty sure that what you are signing and what you are creating is not being tampered with. So this is why we think blockchain is the right technology here.
Great, great. Another question for Alfonso from Amat. He is asking, did you investigate the use of a message broker to solve the MVCC issue? If so, what was the messaging broker you used? Which one?
That's a great question. And actually, yes, we investigated. I mean, we called it layered. I mean, if you see the content we shared, and maybe we should go in depth with this, we called them layer 2 infrastructure, and we follow different approaches based on message queues, and also in the events that the Hyperledger Fabric infrastructure and the chain codes gives you. This is something that we're still evaluating, because we're evaluating if it's better to have a batch approach. We tried with MQTT, and so this is something I cannot give you a specific answer. This is something we're exploring. We are seeing, for instance, we follow an approach that even in the papers they call a fire and forget approach, in which you just throw the transaction, forget about it, and then get the event to know the results. And this is giving us really good results. But I wouldn't be able to tell you a specific broker that it works great, because we tried right now with Redis and with MQTT. It makes sense. It seems to make sense, but we haven't gone into production yet with it. So we will share more information once we have a clear conclusion.
Okay, cool, cool. We have around 8 minutes left, so let's go to another question for Alfonso. How multiple SDKs like HF service can improve throughout where, yeah, this question, I'm sorry, Pavan, could you please re-ask it?
No, I got it.
Okay.
So, yes, we did the evaluation at different layers because of this, actually, to understand what was the bottleneck at different layers. And of course, it doesn't matter if you have, if you have an endorsement policy that is delaying the infrastructure, it doesn't matter the amount of endorsing peers and of SDKs that you put, because the bottleneck will be the endorsing policy. But if you, of course, if in your organizations have more endorsing peers, all of the organizations, you will have a better throughput. But in the end, if there's a bottleneck in the endorsement policy, you won't fix it with more SDKs and more endorsing peers, as long as you don't have the same replication in all the organizations.
Great. Andreas, another question for you. It's not technical. Floos Ruitenkamp is very interested if the blockchain is managed by a consortium, and what are the ideas about the business case? Pay-per-use as a suggestion, question mark?
Well, okay, the first question first. So yeah, the governance and consortium question is something that arises a lot, of course, and we are very lucky that we have the GSMA as a standardization body in the mobile communications industry. So what we are envisioning is that the GSMA will be leading the consortium and also will be governing the blockchain network, actually. So this is our way forward there. And the second question about the business case is, well, the wholesale roaming process is quite complicated, and it's going to get even more complicated in the future, because you have new services like IoT and 5G coming up. And you have third parties that are involved, data clearing houses, and the less you are depending on third parties, the more you can, of course, also reduce your costs. So this is in very simple terms now, is the business logic behind it. So you are reducing your internal and external cost if you make the process more efficient and digitize it.
Clear. And to elaborate on that, Linga is wondering what stage you are on the GSMA to standardize roaming standards.
Well, we have the group in place with the 8 operators that I mentioned. These operators are all committed to bring in their resources, and we already made the first step. So we agreed on kind of a roadmap forward So the architecture, the technology that we want to use. So as I said, for the first steps, it's going to be Hyperledger Fabric. And so we do this step by step. But I guess we are on a good way to move forward here together. But it's a long way because it's a lot of complex organizations working together.
And what were the lessons learned in regards to the governance of the consortium?
Well, the lesson learned is first you need to find a governing body. Of course, one way to do it would be a completely democratic approach, so that you say, okay, for example, if you do a chain code upgrade, then you need a majority that approves it and so forth, which makes the process probably very slow if you have a couple of hundred operators, for example, and IT departments involved. So this is why we said, okay, no, we probably need one neutral governing body there. So this is sort of the outcome of the discussion, and we are very lucky again that we have the GSMA that is already doing that for our industry, also in other areas.
Thank you. The last question is for Alfonso. How did you handle client wallets? And are you offering a custodial service in this?
That's actually a really suitable question, because tomorrow, hopefully, in the blog we had a lot of trouble with, as I've said, we have a dynamic multi-purpose, general purpose, multi-client network. So identities in Hyperledger Fabric are pretty strict with certificates. So that's why we built one of all the models we built in the Trust OS is a Trust ID. That is a decentralized identity approach for Hyperledger Fabric. Hopefully tomorrow we will share in the Hyperledger blog what we've done. And what we do here is that we follow a similar approach of decentralized identity where we can be the custodial. So yes, we have a custodial service, or you can be your own custodial, but following a decentralized identity approach so that you don't have to be forced to belong to an organization in order to interact with the Hyperledger Fabric network. So the answer is yes, we do custodial, and tomorrow, hopefully you will learn how we do this in Fabric, because we also allow the custodial by devs and by users of the Trust OS.
Great. Thanks so much. And thanks everyone for these great questions. I'm sorry we cannot answer all of them. So please feel free to leave questions at the Meetup page itself. I will try to forward them, and you can always directly contact any one of us. In particular, thanks so much, Andreas and Alfonso, for sharing your insights and experience. It's very relevant for us. So thank you so much. And also David from the Linux Foundation for hosting this event.
Yeah, and Rudolph, thank you for organizing this and running it too. Great. Yeah, it was great to see everybody show up and ask great questions. Thank you.
Thanks, and speak soon. See you at the next webinar.
Stay safe, everyone.
Bye-bye.
Bye.
Thanks everyone, bye.